Okay, I'm making this video uh, first as a note on how to, you know, to run this sample application, which was written using event source architecture. Okay, this one is using a Python programming language. I'm using an open source framework for event sourcing called event sourcing. uh, this is the framework that I'm using, and this is the web page of that framework. What I did was providing a, a thin layer, like a wrapper, or whatever you want to call it. This thin layer provide a collection of decorator. You know this, so hopefully these decorators can make make the programming using this framework a bit easier. And uh, the layout of this of an application, of an event sourcing application using this framework is like this. So this is the system, the let's say the bounded context in the domain driven design term, right? So this is the bounded context. It's about dog school, and inside the bounded context we can have one or several aggregates. For each one of those aggregates we have a folder under the aggregates folder, right? So we have an aggregate named dog. An aggregate can accept commands. It makes decision based on the value in the commands and the current state of the aggregate. The decision takes the form of events. So command ins processed by the aggregate, and as an outcome a event is created. So for example, this dog aggregate can take a registered dog command, and as a result we will get an event named dog registered. At this point, the state of the aggregate hasn't been changed. These events will be appended to the event store. You know, there are we can use like maybe MySQL or RDBMS to store these events. We can also use Mongo, and we can also use like a database specialized for 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 uh, for event sourcing. For example, there's a database named Get Event Store. You can check on the website geteventstore.com. Okay, command aggregate event. Then there's a, let's say, a separate thread that pulls those events from the event store and apply each one of those events to the correct instance of the aggregate. How do we does the system know which instance uh, you know to be applied, you know to be applied this event? Well, by matching the ID. Here, when we create this event, we don't specify the ID, right? It's handled by the framework under the hood. We just need to know that the this dog registered event will carry the information about the ID of of the dog. And then the event is pulled from the event store and applied to the aggregate. uh-huh. Okay, in this case, oh yeah, let me go back just a bit. um, I mentioned that this little frame, not framework, this thin layer provide decorators. um, this is an example of decorator. Let's say this command register dog, it has a creation command, so it is telling us that by as a result of processing this command, we'll have an event that will create uh, an instance of dog. So there's some kind of enforcement in that thin layer to make sure that this event, the dog registered event, would be a creation event as well, right? And the apply method of a creation event handler is an instance of the aggregate. In this case, the dog, the the dog aggregate. This is a dog aggregate. Here in this aggregate, we specify, we declare the the properties that a dog can have. In this case, it can have name, it can have list of tricks that the dog has learned, and the IQ of the dog, right? Uh, okay, dog registered. And there's another type of command. For example, add trick. This is a regular command. So regular command uh, is a command for an already existing aggregate. So that's why the signature of the command handler, the first parameter should be the aggregate, the dog, right? And the subsequent parameters can be whatever value you want to have for that command. Okay, for example, here the add trick command will produce a trick added event. The trick added event is a mutation event. So maybe have I mentioned that in the command handler we don't modify the state of the aggregate. We do some domain logic here by based on the properties of the command, based on the current state of the aggregate, we make decisions. But the decision are the mutation. The decisions are the events. So for in this example, we decide that as a result of add trick command, of executing add trick command, a trick added event should be recorded. So we are basically maybe in the functional programming term, it's the kind of side effect free programming. At this point, there is no side effect at all. The side effect is applied in the event handler here. So here we modify the aggregate. So the aggregate, in the aggregate definition here in the dog, we can define whatever domain logic for the dog, right? Here in this case, the trick added will following the functional programming principles. We don't modify the we don't actually mutate the object. Instead, we return a copy of the aggregate with updated values of its properties. So in this case, when the trick is added, we'll get a new dog with the same ID, right? But with more tricks under his belt, right? Okay, command, aggregate, event, event handler, mutation. There's one there's one more thing missing. Something that we call Saga or process manager. So b- by this thing called Saga, we can build a a realistic or complex business process. So here, for example, when when an event trick edit is detected by the system, a process called IQ a process called IQ boosting will be triggered automatically. So IQ boosting, blah blah blah. How do we map that? Well, we have it here. Sorry. Snapshot. No, let me remember how I established that. I believe it's not by configuration, it's by convention. Yeah. So uh, here we define all the processes that we can have in our system. In this example, we have a process named IQ boosting, and we have a folder in process handler, so we can specify, like, just by looking at the layout of the project, we can tell, oh, if there is a dog, if there's trick edit event detected on dog aggregate, then this IQ boosting process will be triggered. Okay, and this is the handler of that detection of that event. Okay, the outcome of this handling the event from a process handler is a comment. So now we complete the cycle. First, there's a command. It enters an aggregate. Then the aggregate emits an event, and then the event is applied on the aggregate, causing the mutation of that aggregate. And right after that, a process is triggered, which in turn will cause a command to be sent to maybe the same aggregate or another aggregate, right? So yeah, so that this will we can build whatever type of process, interconnected process that we can think of, or that we need. Okay. What else? Yeah, I think that's all. I think that's all. So let's have a look at our test application. So what we're doing here is called first call the creation command, the register dog. Then we get the ID of that dog, and then we teach the dog some tricks. First we teach him how to roll over, and then we teach him how to play dead, and then another trick, fetch ball, and that's it. So create, and then 3 tricks. So in total, at the end of this test, at the end of this application, the dog will have 3 skills: roll over, play dead, and fetch ball. So that would be 4 events, right? So let's test that. Pn activate with then and we need to specify the commit sa environment variables. So uh, we also have to think about the versioning. Uh, so why what was the reason for that? Because especially in troubleshooting, we whenever we look at the past issues, we need to know, okay, which version of the code is associated with this problem, so we can avoid uh, using like the latest code trying to reproduce the bug which probably have been fixed, or that kind of thing. So it's important to store uh, the SHA of the code associated with the command, event, all those things. Okay, let's check the table. They're all empty. They're all empty. So let's just run the application. Boom. All right. So we got 6 events instead of 4. Where did the those additional 2 came from? Turns out this is the IQ. They are the IQ boosted events. So we have 2 IQ boosted events. So as I already explained before, as a consequence of teaching your dog a new trick, an IQ boosting process will be triggered, and this IQ boosting process will send a command called boost IQ to the dog. And let's see, a command called boost IQ. Where's boost IQ? And as we already know that a command will create an event. So the fact that the IQ was boosted is recorded as an event called IQ boosted, right? So we got 6 events in total. And so what kind of information we get in an event? Let's go back to the database. So let's, this is the first event. We can tell the name of the event here. It's simple. It's a dog registered event. We can also tell that this event was a decision that came out from processing a command named register dog, right? And that command came with the following parameters. In this case, this is the name of the dog, Fido. We can also tell that the properties of the event. In this case, the dog registered event only has one property, name. So we can tell that. Let's just have a look at the class definition of the dog registered event. You see, dog registered event, property name. Okay, so that's the first event, and then the trick was added to that dog. We can tell that these 2 events are to be applied, or were recorded, to be very accurate. Those events were recorded, or to be applied on the same aggregate. This is the ID of the aggregate of the dog. Okay, so this dog GIW something N. First, it was created, and then it learned a new trick called rollover, and that trick was learned as a result of as an outcome of a command called add trick that was sent to that dog. Okay, and so on, and then the IQ boosted event, shalala. Now let's go back to the definition of the dog aggregate. Dog aggregate here. There's another decorator that we use here called aggregate, and this decorator has a property named snapshot interval. So we're telling the system that for every 3 events, a snapshot should be created. So we have 6 events for that same dog. So we can expect that in the snapshot database we have 2 records for that dog. Let's check that. Right? We got 2 snapshots of the same dog. The first one was created upon or right after handling the 3rd event. In this case, it's right after they created on modified on tricks or offer. How can we tell the event? Well, we don't need the event ID. We can, if we really want to know what event associated with this snapshot, we can simply find it by the originator version. So if we go back to the dog school event, there's a field called originator version. So look for the ID of the dog and the version. So we get this event. We can tell, okay, it was the IQ boosted event. And the second snapshot was for the 6th event, right? So what's the use of having snapshot? First, because an aggregate can have a long life cycle. Probably it can go through like 1,000 events throughout his lifetime. And the way event sourcing works is the finals. We don't store the state of the object, right? That's the idea. We only store the list of events. So that means if we want to, without snapshot, if we want to know the current state of the events, we have to run through all those 1,000 events. That would be a performance problem, right? So that's why we take snapshots. We can, if you don't like the number, you can just increase the value. So it's trade-off between space and time, right? The bigger the snapshot interval, you'll save more space, but there would be more events to be processed for every time you need to act on an aggregate, right? Because you need to run from the latest snapshot to the current version of the event. So let's take, for example, let's say that a snapshot is taken for every 100 events. Now that aggregate has gone through like 150 events. That means you only have one snapshot for those 100 events. The rest, the other 50 Well, to get to the current state of that aggregate, you'll have the code will have to take that snapshot and then apply the remaining 50 events. That's how it works. Okay, that's snapshot. What else do we have here? Yeah, the same. It's IQ boosting events, the same thing. What is the tracking table? Oh yeah, this is special for the Saga or for process manager. It's like a workflow. In a workflow, you always need, or you sometimes need to know in which stage of the process we're currently in, right? So this IQ boosting table has that information. What is this? Notification ID? Notification name. What is tracking? I mean, did I just say something? Interesting track. Oh no, this is something different. Let's see. Why are we tracking the IQ boosting? IQ boosting. Let me remember. Why did I add this tracking tables? Oh, this is not part of the. Okay, this is a domain-specific thing. That tracking thing. I don't remember what was that about. I'm sorry, I wrote this code like 6 months ago, so I don't remember like 100% of that code. I don't quite remember what is tracking tables for. There's an ID. Yeah. So it's not about process tracking, apparently. Yeah. We got events. We store the events. We store steps. So that's all. That's all that matters now. You know, in this video, I don't actually want to focus on this specific framework or this specific example. It happens that I used to be programming on Python, and this framework happens to be good enough, and it works. It's a correct implementation of event sourcing architecture. So it helps. It helps at least. I hope this example, helps you understand the idea of event sourcing. But the more interesting thing is, it helps you to. I hope it helps you to see what kind of information that we get using this. We can get using this this approach. We don't lose anything. There's nothing that escaped our our scrutiny here. For everything that happened in the system, we can tell the the cause. In this case, for example, the trick added event, we can tell, oh, it's because somebody called the add trick function. And furthermore, we can tell also from the correlation ID, we can tell, oh, this add trick command was invoked by this application, for example, this test application with the sequence ID 2. Let's say, for example, you're calling this function from a GraphQL controller. You might want to store the name of the mutation here and the ID of the HTTP request. So you can then we can link that with a log entry, maybe in the cloud, in the CloudWatch, for example, right? and yeah, the we don't lose anything. We have like a complete trace of what was happening on the system, what, when, how, and you can also uh, answer the who question probably by adding by extending this code, this framework maybe just by adding a property to the event and or to the command, the name of the user or the ID of the user that that sends the command. So then what other scenarios that we can enable or improve using event sourcing techniques? Well, first, troubleshooting. That's a very like one of most common use case maybe because let's say let's see from snapshot. Let's say somebody came up with a question or maybe a complaint. Hey, why is the IQ of my dog is so low? I know that I have taught him like 3 or 4 tricks, and I was expecting his IQ would be 140, something like that. Uh, well, we can have a look at those events that from the beginning to up to the point where that IQ, where that state of the dog was observed, and then we can explain what happened by using that by having that audit log, that sequence of events. Probably something was wrong in our code, uh, so we know uh, thanks to the commit SHA that we have here, we can tell, oh yeah, we made a mistake with the implementation of trick added event handler in the specific version of our code. So what can we do from here is, well, we don't how do we call it, we don't roll back here in event sourcing. It mimics better the real world because we don't have this notion of just let's just go back in time and forget what already happened and then just fix that. No, what we do, okay, fine, so this specific case had a problem because of our fault, so we create maybe like a compensating command handler. So yeah, for example, we can have a adjust IQ command, and then this adjust IQ command simply will set the IQ to the value that we specify in the command based on that new value may be calculated with externally or decided by a person, whatever method. But the thing is, we can amend the error that we made in the past using compensating action, and we can justify maybe that compensating action by knowing what leads to that erroneous situation, right? So that's for bug fixing, for error handling, explaining, and we can also, what else? Maybe separately we can with this sequence of events, we can replay it. uh, Maybe as a separate in a separate system. We can get a copy of our the event store, play with it in a separate system, maybe by having has different type of event handling, different way of handling the event, and we can, you know, play what if scenarios, right? What else? Oh yeah, and finally, event sourcing architecture is usually accompanied by another architecture called CQRS, command query responsibility segregation. So basically, what we have here in this sample code is the right side of the system. You can tell that this structure is not very performant for reporting, because we don't have the we don't have a way to join different aggregates. The best structure would be SQL database, right, with all that normalization, denormalization, whatever. So we need the other half of the application, that is the read side. So the idea is, we have the system on the right side, we have something in the middle that will process all these events and build a separate database, uh, separate database designed specifically for the reporting or for the querying requirements for that specific read application. So we can have not just one read side, we can have multiple read sides. Maybe one that reporting database for specific client with some fields drop or hidden, or maybe an encrypted or separate database for our internal data scientists, also with some fields being anonymized, and whatever we can imagine, right? So that's the idea. Event sourcing plus CQRS, we can have lots of flexibilities, and we can have like lots of data, nothing escape our scrutiny or monitoring. Okay, I think that's all. I will end this video here. Thanks for watching.